Good morning and welcome back to section 2 of chapter 7. In this section, we're going to be looking at multiplying polynomials. In the last section, we looked to see what they were, we named them, we saw monomials, and then we added and subtracted. Now the magic words to adding and subtracting was combine like terms. The magic word for multiplication is going to be distribute. So let's take a look. Our learning targets, I can multiply two polynomials. Technically, if you have more than two polynomials, just take them two at a time. So first of all, we're going to multiply a monomial to a polynomial, not a binomial, a monomial. I don't know, that's a weird typo. A monomial to a polynomial. So what is the product of negative 4x cubed and x squared plus 3x minus 4? So the first thing, we can write this, negative 4x cubed times x squared plus 3x minus 4. So to do this, we are going to distribute. We're going to take this whole term, and this has to get multiplied to each of these things. So we're going to end up with negative 4x cubed times x squared plus negative 4x cubed times 3x plus negative 4x cubed times negative 4. I know you might be thinking like, well, no, that's minus 4. Remember, that's just plus negative 4. This just makes sure that our signs stay where they're supposed to be. So now if we multiply this, remember when we multiply variables, we add the exponents. So negative 4 times x cubed times x squared is going to be negative 4x to the 5th. And then negative 4x cubed times 3x, multiply the numbers, negative 4 times 3, it's negative 12. X cubed times x is x to the 4th. And then we have negative 4x cubed times negative 4, so negative 4 times negative 4 is plus 16 x cubed, because we have no more x's to multiply onto that. So that's multiplying a monomial to a polynomial. We distribute and we multiply it out to each of the terms. So try a couple of these. Now these are all negative in the beginning, just because that makes it just a little bit tougher. They could be a positive, in which case the signs wouldn't change. But go ahead and pause me for a second, try these two, and then come back when you're ready. All right, are we ready to look at this? We're going to take this, we're going to multiply to all of these. So we have negative 2x squared times x squared. That's negative 2x to the 4th. We have negative 2x squared times 3x. Negative 2 times 3 is negative 6. X squared times x is x cubed. Negative 2x squared times 4. Negative 2 times 4 is negative 8 x squared. And that's that one. This other one, 4x, negative 4x, we're going to take that and we're going to distribute it to each of these. So negative 4x times 2x squared. Negative 4 times 2 is negative 8. X times x squared is x cubed. Negative 4x times negative 3x. Negative 4 times negative 3 is positive 12. X times x is x squared. Negative 4x times 5. Negative 4 times 5 is negative 20x. So multiplying a monomial to a polynomial, we're just going to distribute that. Now when we're multiplying polynomials, there's a couple ways we could look at these. So if we have something like x plus 5 times x plus 8, one of the ways is we could make a table. When we make a table, we would have one of our polynomials, let's say x plus 5, we'd put it here. We have x and 5. And the other one, x plus 8, would be in the top. It doesn't matter which one's which. Multiplication is commutative, so x plus 5 times x plus 8 is the same as x plus 8 times x plus 5. We can switch those around. And now we have a bunch of monomials, so we could multiply these. X times x was x squared. X times 8 is 8x. 5 times x is 5x. 5 times 8 is 40. And then we can combine our like terms. So we have x squared plus 5x plus 8x is 13x plus 40. That's one way of doing it. The other way of doing it is using distribution. So if we have x plus 5 times x plus 8, we're going to distribute, but we're going to distribute everything in the first set of parentheses to everything in the second set. So this x gets multiplied by both of those. And then the 5 gets multiplied by both of those. So when the x gets multiplied, we have x times x was x squared, and then x times 8 was plus 8x. When the 5 gets multiplied, we have 5 times x is plus 5x, and the 5 times 8 is plus 40. Notice we have the same stuff. And then combine our like terms. We have x squared plus 13x plus 40. So both ways we get it. The table is more visual than the other, but the table can also get pretty overwhelming if we get more than just binomials. But what the table is good for is it helps find areas. So here we have the area. Well, this is just a table. So we can find each of these pieces. If you'd like to, you can pause, give it a shot, and then come back. Or you can wait till we're done with the first one and then try the second one. So when we're finding each of these, we can multiply. So 2x times 5x, 2 times 5 is 10. And then x squared, 4 times 5x, 4 times 5 is 20x. 2x times 2 is 4x, and then 4 times 2 is 8. So we have 10x squared. 20x and 4x is plus 24x plus 8. That's the area. The second one's going to be done basically the same. So you can try that, or when you're ready, we can continue. 7x times 2x, 7 times 2 is 14, x squared. 2 times 2x is 4x. 1 times 7x is 7x. 1 times 2 is 2. So that gives us 14x squared. And then 4x plus 7x is plus 11x plus 2. So that's the essence of multiplying polynomials. So let's try it. So multiplying some binomials, we have, we're going to use more of the distribution method here. So we're going to take this first piece, and we're going to multiply it to both of those. So 2x times x, that's going to be 2x squared. 2x times negative 5 is minus 10x. And then take that 4 and multiply. So 4 times x is plus 4x. 4 times negative 5 is negative 20. Combine our like terms. 2x squared, negative 10x plus 4x is minus 6x. Notice that's not minus 14x, because that's a negative 10 plus 4 is negative 6, minus 20. So a binomial times a binomial, just distribute. So try these two really quick. and come back when you're ready. All right, let's look at this one. So we have 5x times 2x and 5x times 1. 5x times 2x is 10x squared. 5x times 1 is plus 5x. And then we have this negative 4 that'll get multiplied. Negative 4 times 2x is going to be minus 8x. Negative 4 times 1 is minus 4. Combine our like terms. 10x squared. 5x minus 8x is minus 3x minus 4. Notice, by the way, when we're multiplying polynomials and binomials, we get another polynomial. That's called closure. It means it's closure under multiplication. When we're multiplying polynomials, we get another polynomial. We don't get something weird, like we don't have square roots popping up or exponential functions popping up or anything like that. Taking a look at this one, we have the 3x will get multiplied. So 3x times 2x is 6x squared. 3x times 4 is plus 12x. And then the negative 5 gets multiplied. Negative 5 times 2x is minus 10x. Negative 5 times 4 is minus 20. And so we end up with 6x squared. 12x minus 10x is plus 2x minus 20. So multiplying binomials, we can just distribute. Now, trinomials and binomials, like when our polynomials get bigger, nothing changes, except it just gets a little bit bigger, more complicated. So looking at these, we'll do it two ways. We'll use a table, and we'll use distribution. And I'll show you another way to help deal with these when they get a little bit bigger, to help with the organization, because that's actually the trick. It's the organization. If you can stay organized, it's not so bad. So for the table, we're going to, it doesn't matter which one's which, so I'm going to put the trinomial on top. We have an x squared. We have a 2x, we have a negative 1, then we have a 3x, and a 4. So 3x times x squared is 3x cubed, 3x times 2x is 6x squared, and 3x times negative 1 is minus 3x. X squared times 4, 4x squared. 2x times 4 is 8x, and negative 1 times 4 is negative 4. Now, the nice thing here is that our like terms are diagonal from each other. So when we're writing out our answer, 3x cubed, those are all of our x cubed. X squared, we have 4x squared and 6x squared. That's 10x squared. The x's, we have 8x and minus 3x is a plus 5x. And then we have minus 4. So that's one way of doing that. We could use distribution. To distribute, x squared plus 2x minus 1, 3x plus 4, we could distribute going either way. From the first to the second or the second to the first, we could actually rearrange them. Generally speaking, I would put the smaller one in front, but for this case, we won't. We're going to take this x squared and multiply it to both pieces. So x squared times 3x is 3x cubed. X squared times 4 is plus 4x squared. And then the 2x to both pieces. So 2x times 3x is plus 6x squared. 2x times 4 is plus 8x. And then that negative 1 has to go to both pieces. So we have negative 1 times 3x is minus 3x. Negative 1 times 4 is minus 4. Again, notice that these are the exact same numbers that we have in our table. We can combine our like terms. We have the 3x cubed. Then we have some x squareds. 4 of them plus 6 of them is going to be 10x squareds. Then we have x's. 8x minus 3x is plus 5x. Then the minus 4. So that was another way. Another way to organize, and this becomes very useful when we get bigger and bigger polynomials, is we can stack these. So we can go x squared plus 2x minus 1, 3x plus 4. And we're going to multiply. So first we can multiply by the 4. So that's going to be 4x squared plus 4 times 2x is 8x. 4 times negative 1 is minus 4. Then we can multiply by the 3x. So I'm going to start with the negative 1. So 3x times negative 1 is minus 3x. We're going to put that right underneath the like term. And then 2x times 3x was 6x squared. Then x squared plus 3 times 3x is 3x cubed. We can add these together just like when we're dealing with numbers. And notice here our like terms are just stacked. So we have 3x cubed plus 4x squared and 6x squared is 10x squared. 8x minus 3x is plus 5x minus 4. So notice we came up with the same answer. We came up with the exact same numbers in the middle. These are just 3 different ways of organizing what it is that you're doing. You can pick which one's going to work for you on any particular problem. Like, you don't have to always use the same one. Personally, I use this one most of the time, unless I'm dealing with some pretty big polynomials, and then I use this one. Very rarely do I ever make a table, but that's just how I think about it. You can do it whichever way you want. So, let's try a couple. All right, these aren't ones that you're going to want to do in your head, so make sure you have that paper and pencil or something to write with and something to write on, and give them a shot. Then when you're ready, come on back. All right, let's take a look. I'm going to distribute. Again, you're going to see the same numbers, and you're going to see the same answer. So this first one, instead of, we're going to take this 2x and multiply it to each of those things. So 2x times negative 3x squared. 2 times negative 3 is negative 6. X and x squared is x cubed. 2x times 4x. 2 times 4 is 8. X times x is x squared. 2x times negative 7. 2 times negative 7 is minus 14x. And then the negative 5 goes to everything over here. Negative 5 times negative 3 is positive 15x squared. I could keep writing it in a big long line, or I'm going to stack these. So negative 15x squared, I'm going to put it right by my other x squared, because I know that we're going to combine those. Negative 5 times 4x, negative 5 times 4 is negative 20x. Negative 5 times negative 7 is positive 35. We can add these together. So even though I didn't stack the problem, I was stacking my answer, which was just putting those like terms next to each other so that they're easier to pick out when I'm combining them. Negative 6x cubed. 8x squared minus 15x squared is minus 7x squared. Negative 14x minus 20x is minus 34x plus 35. All right. This one, we can do the same way. We're going to take this negative 3x squared and multiply it to all these pieces. So negative 3x squared times 2x squared, negative 3 times 2 is negative 6. X squared and x squared is x to the 4th. Negative 3x squared times 3x, negative 3 times 3 is negative 9. Then we'll have an x cubed. Negative 3x squared times negative 4, that's going to be a plus 12x squared. And then the 1 gets multiplied. Well, when we multiply this by 1, we're going to just get the 2x squared plus 3x minus 4, because when you multiply something by 1, you get it. We can add these together. Notice, again, when I put my numbers, I grouped them so that the like terms were next to each other. So I can see that the only x to the fourth is this minus 6x to the fourth. The only x cubed is this minus 9x cubed. We have 12x squared plus 2x squared is 14x squared. And then we only have that one 3x and the minus 4. So there's how we can multiply. And if your polynomials are getting bigger, like if you have a trinomial times a trinomial, you just multiply all three things in one to all three things in the other. And you can make these as big as you want. The only thing that changes is the organization. Like it becomes more and more important the bigger they get. All right, let's look at an application. So we have a smartphone has a screen that has a width of x and a height that is 1.8 times the width, and then the outer dimensions are shown. Write an expression for the portion of the phone that is not occupied by the screen. And then we're going to assume it's a rectangle, so the rounded corners we're not going to worry about. So we have x, and this is 1.8x for the screen. So we're going to multiply to find the two areas, and then we're going to figure out how much of it's not the screen. So the phone itself is going to be the outside. It's going to be the 1.8x plus 3 times x plus 1. And then the actual screen, we have 1.8x times x. So let's multiply the actual phone. 1.8x times x is 1.8x squared, and then 1.8x times 1 is plus 1.8x. 3 times x is plus 3x. 3 times 1 is plus 3. So we just distributed those things. We can combine our like terms. 1.8x squared plus 1.8x plus 3x is 4.8x plus 3. All right, so that's the area of the phone itself. All right, how about the screen? 1.8x times x, well, that's just 1.8x squared. And now we want just the part that is not the screen. So if we took the whole phone and we took away the screen, that would give us the part that's not the screen. So we're going to subtract. It's going to be the whole phone, 1.8x squared plus 4x plus 4.8x plus 3 minus the screen, 1.8x squared. Combine our like terms. Well, those are the x squareds. 1.8x squared minus 1.8x squared, that cancels out. So what we're left with is 4.8x plus 3. And that would be the area of the phone, the proportion of the phone that's not occupied by the screen. It's the black area. It's we're looking at this part of the phone. All right. So today, it was way more focused than the first section. The first section had a lot of definitions. Today is just multiplying. And again, there's a few different ways of doing it. There's a few different ways of organizing your work. But the magic word of multiplying polynomials is distribute. So I will see you in class. But until then, keep working problems, keep asking questions, and as always, happy mathing.